This problem number 22 of the MIT integration big qualifying exam 2012, the indefinite integral of x times hyperbolic cosine of x over the square of the hyperbolic sine of x. So this is a fairly tricky problem. Let's see how we may be able to solve it. So, okay, let's look at our problem here. I think we're going to use integration by parts here. And what is integration by parts? That is, if you have a function that consists of a product of a function u and the derivative of a function f, right? This is the same as uv minus u times the derivative of x, right? And this really comes when you try to differentiate uv, right? It's the sum of the derivative of v times u plus derivative of u times v. And so when you rearrange it and integrate, you get this. So this is what we're going to use today, right? X hyperbolic cosine of x, or cos x, over hyperbolic sine squared. Notice I've brought the square in because that's the usual way of writing it. Hyperbolic sine of x squared x, or sinh squared x, can be expressed as x. And since we know that the derivative of sinh of x is cos of x, right? We clearly see that cos x is the derivative of sinh x, so we have right over right, which is also equal to x times the derivative of an over sinh of x, right? So because that's what we have there. And now we see here clearly that this is our v from here, and this is our u, right, from here. So this means that our problem now becomes uv, which is x over sinh of x, minus negative of sinh of x, 1 over sinh of x, times the derivative of x, which is 1. Is x over sinh of x. This negative and negative interact, so we have 1 over sinh of x dx. So this is where the problem becomes a little bit complicated, and let's see how we may be able to solve it. Our problem is x over sinh of x plus the integral of 1 over x. We can express this sinh x as a single variable, or the half variable format, sorry, which is 2 sinh of x over 2 cos x over 2. Okay, which is interesting because now I could also go ahead and say that this is the same as 1 over 2 sinh x over 2 cos squared x over 2 over cos x over 2, right? So this becomes negative x over sinh of x plus, we said we had 2 sinh x over 2 cos squared x over 2 over cos x over 2 is x over sinh x over 2 plus cos x over 2 over 2 sinh x over 2 cos squared x over 2. Okay, so this becomes negative x over sinh of x plus a half, and we have on top here cos of x over 2 over sinh over 2 cos squared x over 2. Now what we see here, we definitely do see we do see a tangent in the denominator, and we do see, so essentially what we have here is hyperbolic secant x over 2 over hyperbolic tangent x over 2, and what we have in the numerator is the derivative of, without this, the derivative of x over 2 at hyperbolic tangent of x over 2. Okay, so and this leads us to knowing that the integral here is essentially the natural logarithm of whatever is in the denominator, which is equal to x over hyperbolic x plus the natural logarithm of the hyperbolic tangent of x over 2 plus the integration constant, right? So in other words, our integral of x times cos x over equals to x over hyperbolic sine x plus the natural logarithm of hyperbolic tangent x over 2 plus the integration constant. That is, ladies and gentlemen, our answer. Thank you very much for your attention. Until next time, bye-bye.